these compounds are left in air, they will start absorbing water vapor from air, right? And they will keep absorbing water vapor from air and will form saturated solution, right? So I'll just rub this. So deliquescence is little opposite of efflorescence. If you know one, you can easily remember the other. Deliquescence would be when these salts like magnesium chloride or sodium hydroxide left in air, like when these are left in air, what these will do, they will absorb water vapor, right? They will absorb water vapor and they will form saturated solutions, right? So this is important. These salts will absorb water vapor from air and they will dissolve in the water vapor that they absorb to form a saturated solution, right? They will absorb water vapor and dissolve. I'll just write it dissolve here. Dissolve, forming saturated solution, right? An example is sodium chloride, magnesium chloride, calcium chloride, ferric chloride, sodium hydroxide, potassium hydroxide. So whenever you leave these salts in air, they will absorb water vapor, right? And they will dissolve in the water vapor that they have absorbed from air and form saturated solutions. Now there is one question that has been asked many times. Sodium, why table salt? We know what is table salt. Table salt is sodium chloride that we use in our homes, right? That we normally use in our home. Why table salt become moist in rainy season? Why? It's because the sodium chloride salt, this is not deliquescent salt, right? If it's not deliquescent, then how does it, since I said it becomes moist in rainy season, you might have noticed that if you leave salt outside for some time in rainy season, it will absorb water, right? It will become moist, right? Why it happens? It's because it's not deliquescent, but it contains some impurities like magnesium chloride and calcium chloride, due to these impurities, it's actually these impurities, magnesium chloride and calcium chloride, that absorb water vapor from air, right, and dissolve in it, forming a saturated solution. So that is why you will notice that salt, right, table salt will become moist in rainy season because of these impurities that will absorb water vapor from air. So why it becomes moist? Because due to deliquescent impurities like magnesium chloride and calcium chloride, right? So this is deliquescence, right? You can just take all these things down, right, so that you will remember it. Now hygroscopy. Hygroscopy is also little similar to this, but they will also, hygroscopic substances also absorb moisture from air, but hygroscopic substances won't dissolve in the absorbed moisture, right? That is, they will not absorb enough moisture, or they will not dissolve in the moisture that they will absorb from air, right? So deliquescence is certain water soluble substances when exposed to air absorb moisture, become moist, lose their crystalline form and ultimately dissolve, forming a saturated solution. If say magnesium chloride is in crystalline form, we have seen that since we've spoken about this sodium chloride, we know that dry salt is crystalline, right? You see some small crystals of salt, right? But in rainy season, when it absorbs water vapor from air, it will lose its crystalline form, right? when it will absorb water vapor, it will lose its crystalline form and will form a solution in water. It will become very moist, that it loses its crystalline form. So deliquescence will absorb moisture from the atmosphere, right, and dissolve in it, right, whereas hygroscopic substances absorb moisture but will not dissolve in the moisture that they absorb, right. So hygroscopy, I'll just write it over here. Hygroscopic substances are like concentrated sulfuric acid, phosphorus pentoxide, right, and quicklime. What is this quicklime? Calcium oxide, right. When left in air, they will absorb white water vapor or moisture, right, but will not dissolve. Since they absorb moisture from air but will not dissolve in the absorbed moisture, right. So they are also, all the hygroscopic substances are used as drying agents, right, to dry gases. If you will prepare gases in the lab, right, or in the future lectures when we study the preparation of gases like chlorine or ammonia or sulfur dioxide, right, these gases are dried, right. After passing through, these gases are passed over concentrated sulfuric acid or quicklime or phosphorus pentoxide, right, to remove the moisture that is associated with the gases, right. So these hygroscopic substances are also used as drying agents, right. So what are drying agents? Drying agents will absorb moisture from the gases, right, without itself associating or without itself reacting with the moisture that they absorb. So these hygroscopic substances like concentrated sulfuric acid, P2O5 and quicklime will absorb moisture but won't react with the water that they absorb from atmospheric air, right. So just take all this down. So we have something called as drying agent, and you might have also heard of something known as dehydrating agent, right. We have, so hygroscopic substances like calcium oxide or concentrated sulfuric acid these are drying agents, right. What are drying agents? They will absorb moisture from air, or they are used to dry gases, so they will absorb moisture from gases, right. So dehydrating agent, there's a little difference between drying agent and dehydrating agent. And one more thing, to drying agents we also call these as desiccating agents. We also call these as desiccating agents or desiccators. Desiccator is kind of a container which has a drying agent in it, right, and you can put, it's an airtight container that has a drying agent at the bottom, right, and the work of that drying agent is to absorb moisture from any substance that is placed in the desiccator, right. You can see that diagram in the book. It's kind of this kind of diagram. So here you can put a drying agent, right, and it's an airtight container. You can put any substance that from which you need to remove moisture, right. Now we have something called as a dehydrating agent. This is, we call it as a desiccator. This is a desiccator. Now we have something called as a dehydrating agent, which are little similar to these, right? But little different. What dehydrating agent will do, dehydrating agent, what dehydrating agent will do, dehydrating agent will remove moisture, or it will remove chemically molecule of water from other substances, right? It will remove chemically water molecule from other substances. For example, what do we mean it remove chemically water molecule from other substances? That is, it will remove this water molecule, which is two atoms of hydrogen and one atom of oxygen. So dehydrating agent will chemically remove this water molecule from other salts or other substances. For example, copper sulfate pentahydrate. So what dehydrating agent will do, it will remove these associated water molecules. For example, dehydrated concentrated sulfuric acid is also a dehydrating agent, right? So these water molecules will get removed. These water molecules will get removed from the salt using dehydrating agent. They will chemically remove a water molecule or more than one water molecule from any salt, right? So there is a difference, little difference that you can see in your books. The drying agent, it's a physical process since it absorbs moisture, right? It's a physical process, and this would be a chemical process. Why? Because it's a change, right? It's a chemical change because it's removing water molecule from this salt. So this is a chemical change, right? And you can it's like formic acid, right? It's a chemical change. So if you put concentrated sulfuric acid, which is a dehydrating agent, it will form CO plus H2O, right? It will form carbon monoxide. Similarly, if you take C12H22O11 sugar, this is sugar, the dehydrating agent will remove chemically water molecules from this sugar, right? And it will form sugar charcoal, right? If you put concentrated sulfuric acid to it, it will form carbon plus water molecule. This would be known as sugar charcoal. So these two reactions will prove that concentrated sulfuric acid, which acts as a dehydrating agent here, it's a drying agent as well as dehydrating agent, so don't get confused, right? So concentrated sulfuric acid will remove all water molecules from sugar, producing sugar charcoal and water. It's a balanced equation. So this is sugar charcoal. Right. So you can just take down all the notes, and I hope all this is clear to you. Thanks.